Okay, with the data sorted, let's make a common type of diagram to display the data. And that diagram is called a histogram. The goal of a histogram is to give a viewer a really quick and easy overview of how often different types of numbers happen. In this case, we're going to look at close prices. I want to display the closing price of this stock to someone who doesn't know a whole lot about it. So what I'm going to do is break up the closing prices into a bunch of different categories. For example, if you look at the closing prices in September, $37.34 is not wildly different than $38.09. But $38.09 is clearly very different than $29.21. So I want to group up these closing prices into buckets of very similar data points to try to convey whether the data is more likely to be clustered around $29 or more likely to be clustered around $38. So the first step to do that is to figure out just how spread out the data is. So we know we can compute the minimum of a data by applying the min function and selecting all the data. And we can do the max just like that. And that's no problem. And we see there very quickly that the stock over the data set that we have goes from $27.73 to $40.55, just looking at the closing prices. So let's create some bins or some buckets or some ranges that we can cluster that data into. So we can come with whatever ones we want. There's a little bit of an art to this. I'm going to pick the following buckets. I'm going to pick, say, less than $30. Let's say 30 to 35, 35 to 40, and greater than 40. So I'm going to cluster all the data on closing prices into one of these four bins. And now what I need to do is go through the data and say, well, how often is it less than 30? Well, how do I do that? I want to count how often it's less than 30, but I only want to count if it's less than 30. So I want a COUNTIF statement, right? I'm counting the data subject to a condition. So I select all the data, and then I need to put in my criteria. And the criteria here is less than 30. So if I do that, I get 6. Well, greater than 40 is very easy as well. All the data greater than 40, COUNTIF, and boom. So very quickly I can get that 6 are less than 30, 4 are greater than 40, but I still have two bins. These are a little trickier. One-sided COUNTIFs, less than, greater than, are always going to be easier than two-sided COUNTIFs, between 30 and 35. The easiest way to get this 30 to 35 bin that I'm looking at right now is to say, well, let's count all the numbers, all the closing prices from 35 down, and throw away the ones that are 30 and below. And since I just counted the ones that were 30 and below, I can do that very easily, right? So I'm going to do my COUNTIF on all the data from below 35, and then I'm going to throw away what I just counted by subtracting it off. So this tells me that I have 9 prices between $30 and 35 prices. That is 15 minus 6 once I throw away the ones that were below 30, because we don't want to double count those. Similarly, if I do another COUNTIF here, I could count, for example, all the prices that are greater or equal to, say, 35, and then I could throw away the ones that are over 40, leaving me with 11. If I do a quick count, or if I sum these up, you'll notice that I get 30 observations, and 30 observations is exactly what we have in our data set. The final step, go up to insert a graph of your choice. Let's make a bar graph, columns, bars. Here's a histogram. You can play around with the descriptive as much as you want, but it gives you a very easy way to see that how much the data happens to fall in certain ranges. A very comprehensive way to look at the data, and one that's going to have a lot of strong analogs to certain statements about mathematics and probability later in the course, which is why we're spending time on it now.